is we're going to do horizontal roughing to remove, this is a prototype insert block. So this is all one block. So we got to remove all the material around this core. So we're going to be going with horizontal roughing, 3-axis. And the operations I'm using are the operations is available in the standard configuration. So we're not going to be doing anything that you cannot do in the standard configuration. So for horizontal roughing, for the control geometry tab, we're not going to select anything. As you know, if you're familiar with our CAM products, there is a certain amount of intelligence built in to the toolpath algorithm, so it automatically knows where the part is. Okay, and actually I didn't set the stock, so let's go ahead and cancel that a minute. Let's go to our stock, and we're going to do a copy model bounding box so we can see the dimensions of our part. And that is 28 inches by 27 by 13.09. So we're going to just put a little bit of material here, which is just 0.25. Okay, just to extend that a little bit above this top area right here. So we're going to pick OK there. And we're going, since we did add material, we're going to go ahead and align the stock. And we're going to align it with the bottom of the insert block so that the extra material extends above the part on the top, and it's going to be centered. Okay. So we'll pick OK there. So here's what our stock looks like. Let's go turn that off for now. Now let's go back into our horizontal roughing operation. As I mentioned, we're not going to select anything here. It's going to automatically calculate all the material that it can remove based on the part material, the stock material, and the cutting tool that you're going to be using. So for the tool, we're going to be using our flat end mill. Okay, so it's a 1-inch diameter, 8-inch long flat end mill that we're going to be using. And we're going to skip the feeds and speeds. For clearance, we're just going to use the default clearance plane parameters. Automatic for the clearance plane definition, we're going to set the automatic. And for the cut transfer method, this is where the tool retracts to change directions. We're going to leave that set to the clearance plane. Okay. Now for cut parameters, we're going to leave it a tolerance of 10 thousandths, and we're going to leave some 25 thousandths of stock material on the part. So we're going to have multiple cut levels, but no cut level will come closer to the part than 25 thousandths. Okay. And we're going to be using a offset cut pattern. So the roughing will do successive offsets of the shape of this core region. We're going to be allowing a mixed cut direction. So the tool can go both right and left in both directions. We're not going to limit it in a climb or a conventional configuration. We're going to let it mix. We're going to start machining on the inside. So it'll probably start on the inside up here and work its way down. And we're going to set a step over of 25% of the cutting tool, which is 1 inch. So the step over is going to be 1/4 of an inch. Okay. And we're going to leave corner cleanup. We'll leave that set to none. And let's see what else we got here on the cut levels. Okay. For cut levels, the step down is going to be 50%. So it's a 1/2 inch. So this is relatively soft. It's not treated steel or anything. So this is relatively soft material. So we're going to, well, the main step down is going to be 50%. So here is where you can set your step minimization. If you check this box here, you can give it a secondary step down. So if you look at the picture right here, the dark orange, okay, or sorry, the lighter orange is your initial 50% step down. So you have a large step, okay. It's called DZ. and the darker orange will be your minimization. So what it's going to do is it's going to start cutting it at 50%. It's going to go through the entire cut at 50%. Then it's going to come back. It's going to cut additional levels at 25% using the same tool. So the first passes will be at a ½ inch, and the second step minimization pass will be at a ¼ inch, 25% of the 1 inch diameter. Okay, and we're going to do a depth first cut pattern, and this is a critical area here. If you're familiar with our product in roughing, horizontal roughing, you know that we can clear the flats, we can tell it where to start, where to stop. I'm not purposely not selecting anything here. So what's going to happen is it's going to take everything it can down to the parting plane, but it's not going to clear the parting plane. What you don't want to do is you don't want to have that sharp corner, that flat end mill anywhere near this parting edge. Okay, so we're going to do that in a separate special circumstance situation. Okay, so the cutter is not going to clear the flat, so there's going to be material left here at the bottom. Okay, engage and retract. We're just going to leave it in the default values, helical entries. And let's see what else for advanced cut parameters. We're going to allow it to find arcs. This is not really critical in the roughing, but we'll leave it. We'll leave this set to 02. So arc fitting should be recommended to be 2 times your cut tolerance. So our cut tolerance is 10 thousandths. So our arc fitting is going to be 20 thousandths tolerance. Okay, we're not going to do any toolpath optimization. Let's go ahead and generate that. Now, while I'm generating, it's a good time to think if you have any questions, you can type them into the questions panel while this is calculating. And this will take a little bit of time. Any questions, Joe?
Nothing yet,
Okay.
but maybe you can talk about tolerances and generation speed. Maybe I can talk about it.
Okay.
Well, it's done, but one of the things you can do to speed up, if you're doing what if scenarios when you're machining, I would recommend setting tolerances, slack tolerances and generating it. Things will go quicker. And then once you're ready, once you got the program all figured out and exactly how you want it to do, then you can come back in with your final tolerances and do the final programming.
That's a good tip there. Also, what you can do is your step overs. Maybe initially you don't need to be a really tight step over. If you just want to get a good look at what this path is going to look like, you just give it a wider step over, as Joe mentioned, a more lax tolerance, and that'll help speed it up as well. So we got through. Let's look at what this. So I got a number of toggles here. I've got the toolpath display turned on. This is toolpaths that are hidden. I'm going to turn this off just to clean it up just a little bit. And I'm going to look at the cut levels here. So you'll see that the last cut level is above the parting plane. I don't want this roughing to go down to the parting plane. Okay. So we got multiple levels. And then we also have, I'm going to set a property here, a color property. So the color of this operation during simulation is going to be this color right here. Okay. And let's go and do the simulation so you can see the step minimization. Let's go up here. I'm going to turn the toolpath off for now. Okay. And let's go ahead and make this as fast as I can just to get through that. And I'm going to set, if you want the colors, we set specific colors to each operation. If you want to see those colors during simulation, you need to set this to MOP. MOP stands for machining operation. Okay, so now we're going to, so it's working its way down. So it's doing out here, working from the outer end, is doing the half inch, 50% step down. And let's go ahead and change something here. Okay. And let's change something else here. Okay. So now you can see. So it did, what it did was it did half an inch step downs out in this area here. When it got to the part, it did an additional 25% step down with the same tool. So it's like a roughing operation, and I mean, it's like a re-roughing operation at the same time as it does the main roughing operation. So you can work it down further, and you can adjust that to whatever you want. It's set to 25% here. So each one of these step downs is 1/4 of an inch instead of a half an inch. So this comes in really handy if you want to do a re-roughing, and it's okay to use the same tool, then you can do the step minimization. And on the opposite side of what the outcome will be is that not only does it add additional step downs here, but it eliminates from you having to do all of it in one half-inch step down, which means you would have to come back in maybe with another operation, maybe with another tool to work it down. We're doing it all in one operation using the step minimization options that are available in the horizontal roughing. Okay. Now,